Hello dear students, today let us discuss one more concept, that is combination of thermal conductors. Last time in the last video we have seen what is a thermal conductivity, how it is depending on other factors, and formulas for that also we have seen, and we have seen that the thermal current and the thermal resistance etc and the thermal gradient, all those points already we have discussed. Now today let us discuss one more concept in this thermal properties, that is the combination of thermal conductors. There are the two combinations are there. One is series combination of rods and one more is a parallel combination of the thermal conductors or the rods. Now in this series combination of rods, let us consider two conductors. First conductor length is L1, second conductor length is L2, and here the area of cross section of the each rod is the same. Means what? For the first conductor area is A and the second conductor also area is A only. So now when two conductors of the same cross sectional area A with the same length L1 and with the different lengths L1 and L2, and thermal conductivity is K1 K2. Means what? First conductor thermal conductivity K1 and second conductor thermal conductivity K2, and first conductor length is L1 and second conductor length is L2. Then if these two are connected in series, what is the meaning of series combination? If two rods of same length are connected end to end, means what? This is the end of the first one, this is the starting end of the second one. Therefore these both ends of the rods are joined together. Such combination is called as a series combination of the rods. Now in this case already we have discussed the formula for resistance, thermal resistance. The effective thermal resistance formula in series combination, S suffix refers to series, therefore that Rs is equal to R1 plus R2, and here Rs is equal to, in place of the R1 just you substitute L1 by K1 into A plus L2 by K2 into A. Here already this is the formula for thermal resistance in the thermal conduction. The effective thermal conductivity, generally K1 is the thermal conductivity of first and K2 is for second. If these two are making one new rod, means what? By combining this we are constructing new, therefore you will get that effective thermal conductivity Ks is equal to L1 plus L2 into K1 K2 by L1 K2 plus L2 K1. This is somewhat confusion factor is there. Please be careful that that formula is L1 K2 plus L2 K1 in the denominator. Now the heat current through the rods is the same. Means what? When two conductors are connected in series combination, the heat current through the first rod and the heat current through the second rod both are the same. If you consider this is the heat current through the first one is I1 and through the second one is I2, then the heat current compulsory same, because there is only one way to flow the heat. Therefore I1 is equal to I2, and you know that here for example if theta is the junction temperature, here theta is the junction temperature. Now the temperature difference between these two is theta 1 minus theta, and here temperature difference between the second rod is theta minus theta 2. Therefore now here the current formula we know that temperature difference by the resistance. Therefore for the first conductor and theta 1 minus theta by R1, that is equal to theta minus theta 2 by R2. Therefore now here we got this formula by using this simple concept, that is the heat current through the each rod is the same. And from this formula or from this discussion we can find out the junction temperature theta. Already we have discussed that, and here this theta, and at the junction that temperature is there, no, that temperature theta is called junction temperature. And in this junction temperature the formula by using this concept we can calculate, because just you take the cross multiplication of this and you substitute the R1 value here. R1 is equal to L1 by K1A and L2 by K2A. Just you cancel the A, and you will get the final answer that theta is equal to K1 L2 theta 1 plus K2 L1 theta 2 by L1 K2 plus K1 L2. And for example instead of the two rods, if you connect more number of the rods in series combination. So in this discussion we have taken only 2 rods in the combination, but if you take multiple number of, means what, first rod, second rod, to the second, third rod, fourth rod, like that, therefore for the number of multiple rods, therefore the simple formula to calculate the effective thermal conductivity, the formula is L1 plus L2 plus L3 plus and so on by Ks. Here Ks is nothing but the effective thermal conductivity in series combination, that is equal to L1 by K1 plus L2 by K2. And here for the 2 rods, the thermal conductivity formula already we have given, that is the effective thermal conductivity Ks is equal to L1 plus L2 into K1 K2 by L1 K2 plus L2 K1. This is only for 2 rods, and this is for multiple purpose. For many number of the rods we have to use this formula to solve the problem, and for the multiple number of rods in series combination, the effective thermal resistance Rs is equal to R1 plus R2 plus and so on up to Rn. Now let us discuss the second combination, that is called parallel combination of rods. Here nothing, just in the series combination we have connected the 2 rods end to end. Here the 2 rods should be connected surface to surface. For this purpose, in the first case we have taken the lengths of each rod is different, but in this case the length should be same and areas are different. Therefore now when 2 conductors of different area of cross section with the same length are connected surface to surface, such a combination is called as the parallel combination. And in this parallel combination, let us discuss the various formulas for this case also. Now the effective thermal resistance in this parallel combination is for the 2 rods, Rp is equal to R1 R2 by R1 plus R2. If you simplify, you can get one simplification, that is 1 by Rp is equal to 1 by R1 plus 1 by R2. And for second 2 conductors we can use, and you can use this one also. And the effective thermal conductivity in this case is Kp is equal to K1 A1 plus K2 A2 by A1 plus A2. And the temperature difference across each rod is the same. In the first case, in the series case, we have seen that the thermal current through the each rod is the same, but in this parallel combination, the temperature difference across each rod is the same, but the thermal current is different. It means what? In different rods in parallel combination, the current is not same, the current is different, but the temperature difference is the same. Therefore now here we know that the current formula I is equal to theta 1 minus theta 2 by R. As I told you, theta 1 minus theta 2, this is called as the temperature difference. This temperature difference is the same, therefore you take this R this side, it becomes I into R is equal to theta 1 minus theta 2. Therefore from this one, for the first conductor, that is I1 R1, for the second conductor, that is becomes I2 R2. Therefore now as theta 1 minus theta 2 is equal to constant, therefore the product of the thermal current and thermal resistance in any rod of the parallel combination is the same, that is the I1 R1 is equal to I2 R2. And for multiple number of the rods, just you add extra terms that already we know that for the 2 conductors Kp is equal to K1 A1 plus K2 A2 and plus K3 A3 plus K4 A4 and so on up to Kn An by total effective area, that is nothing but A1 plus A2 plus and so on. And in this case, for the many number of multiple rods, the effective thermal resistance, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 and so on up to 1 by Rn. Here some important note points are there for the solving the problem. The first point is that for the given identical rods, here what is the meaning of identical? Geometrical parameters are the same. Here the geometrical parameters are nothing but one is the length and one is area of cross section. When they have mentioned the given materials are the identical, length and area should be taken as same. And if they will mention the same material for the same nature of material, means what? If you take copper rods, if you take the iron rods, if you take the silver rods, means what? For the different rods the K value is different, but for the same nature of material, means what? For the given 2 copper rods the K value is the the same. Means what? When the given material's nature is the same, the thermal conductivity is the same. And one more important formula in all about two cases we have discussed, parallel combination and series combination. In that, sometimes they will ask that what is the total heat current through the combination. That simple formula, the current through the, the thermal current through the combination is given by, so the temperature difference across the combination by the total effective thermal resistance in this combination. If it is a series, just you substitute in place of R effective RS, and if it is parallel, you substitute RP in place of the R effective. Therefore, this is the thermal current in the effective combination. Now let us discuss some numericals on this case, and here the very important question it is, they have given 3 rods AB, BC and BD of same length, same area and same nature. As I mentioned, what they have given, same length, same area, means what? Geometrical parameters are the same, and they have mentioned same nature also. Means what? For the given 3 rods, the thermal conductivity is the same, length is the same, area also same. What they have given are connected as shown in the figure. So the temperature of the junction B is, here this is the question, and in the problem they have not mentioned the temperatures, but they have given here in the diagram they have mentioned at the end A the temperature is 20 degrees Celsius, at the end C that is 80, and at the end D that is 80, and at the B they are asking what is the temperature at this junction they are asking. So now first of all let us assume that theta is, means what? The theta is the temperature at B, at the junction B. For example, let us assume that theta is the given temperature, and let heat current starts at D then. So here one important observation point, you may take the current start, here the current means thermal current, here the thermal current may start from D, either thermal current may start from C, or thermal current may start from A. So you can select any one of the starting point from the figure. I am assuming that from the D the current is flowing. Therefore now let us substitute that this current I am taking that current is I1, and in this case the current, for example the current in this case I am taking that I2, and in this case the current I am taking that is for example that is I3. Means what? The current flowing from D to B, at the B it is dividing into 2 parts. One current is going through the conductor BC, and one more current is going through the I3, that is BA. Therefore the current I1 is equal to sum of the I2 and I3. Why? Because this sum of I2 and I3 when you are adding, that is nothing but the I1 only, because I2 or I3 both are generated due to the current coming from the junction, that point D, that is I1. Therefore now here from the figure you can select that I1 is equal to I2 plus I3. And what is the thermal current? Just now only I told you that the thermal current formula, that is I is equal to temperature difference by thermal resistance, and thermal resistance formula L by Ka, just you substitute, and here I1 as theta delta theta. Therefore this is theta 1, this is theta 2 for this this is theta 2 for this combination. Therefore now you can select that I1 in place of the I1, theta 1 minus theta 2. This is the theta 1 and this is the theta 2. Therefore now 80 minus theta by L by Ka, because thermal resistance R is equal to L by Ka. And here for the I2 means it is going from B to C, and at the B the temperature is theta, and at the C the temperature is 80. Therefore theta 1 minus theta 2. Therefore now here L by Ka as usual, and here similarly from B to A you can select this one. Here L by Ka cancel, the remaining is here the remaining term is 80 minus theta, and here that is 80 theta minus 80 and theta minus 20. Here if you add these two terms, so theta minus 80 plus theta minus 20, you will get that theta plus theta, that is equal to theta minus 80 minus 20, that is becomes minus 100. If you simplify the problem, you will get the answer, the temperature at the problem at the junction of the diagram, that the B, the temperature that is equal to 60 degrees. Here I am giving one problem to you, all of you. We have to solve this solve the same problem like previous problem only. Here what they have given, two identical and same nature rods are connected at their midpoints. This is one rod and this is one more rod. This is the midpoint, and therefore the question is the temperature of the junction is, and here also they have mentioned the temperature at the ends of the rod. And please solve this problem. The answer is 82.5 degrees Celsius temperature at the point O. And here you can select any point to flow the or to start the current. point. You may select either from D the current is starting, either from A current is starting, either from B or either from C. You can select any one point, and same you follow like previous problem to find out the current at the junction, and you will get the temperature at the junction, that is 82.5 degrees Celsius answer you will get. And please all of you once again you take this problem and solve all of you. Now let us discuss one more problem. That problem is two plates of the each length 2 meters and area of cross section 1 centimeter square. Here observe the units difference. Here they have given 2 meter, here they have given centimeter square. Compulsory area should be converted into SI units and of same nature. Same nature means what? They have given two rods with the same nature, means the thermal conductivity should be same with the thermal conductivity 2 units. Here they have not given units, therefore we have to take as usual, no problem. Each are connected in series combination, and if end temperature of the rods are 100 degrees Celsius and 0 degrees Celsius, then what is the heat current in the combination? So in the theory discussion we have seen the last formula. Once again you go back and you see the formula, the temperature, the thermal current in the given combination I have given already. And here let us take that this is the first rod, this is the second rod, both are having the same length L and L they have given, that is 2 meters each length, and area of each is 1 centimeter square, and both thermal conductivity are the same, that is they have given, that is the 2 units. And therefore here that the first junction they have at the first end, that is the temperature 100 degrees Celsius, and at the second end that is 0 degrees Celsius. Therefore you have to find out what is the heat current or what is the total amount of the heat flowing per second, you have to find out. And we know already the formula, the effective thermal resistance. First of all we have to find out the effective thermal resistance. Here they have given it is a series combination. In the series combination the formula is R1 plus R2, and you substitute that R1 is equal to L by Ka and R2 also L by Ka. Why? Because both are all identical. Therefore now if you solve you will get the 2L by Ka. Substitute the values, you will get that the effective resistance, I mean the effective thermal resistance, that is equal to 200 units. Now the answer, the final answer, what they are not asking the thermal resistance, they are asking the thermal current. The thermal current that is I is equal to formula already we know that theta 1 minus theta 2 by Rs, that is equal to 100 minus 0 by 200. You will get that is the half unit of thermal current is flowing in the given combination. Now let us discuss the last problem, that is the fourth problem, and they have given two conductors of the same length. Here they have given same length, area of cross section 3 units and 6 units. They have not mentioned any unit properly. Therefore with respect to thermal conductivity 2 units and K units, here this is K units are connected in parallel combination. If effective thermal conductivity is 4 units, then the value of the K is equal to. Therefore here you have to find out, for example this is the first one, this is the second one with area A1 A2, and here they have given that is equal to K. K is equal to question mark. Here we have to find out K value only. Here in this problem it is need not to find out the effective thermal conductivity. Why? Because the effective thermal conductivity value they have already given, and these are in parallel combination. Therefore in the parallel combination we know that the thermal conductivity in parallel combination Kp is equal to K1 A1 plus K2 A2 by A1 plus A2. Just you substitute the value, they have given the effective thermal conductivity in parallel combination Kp is equal to 4 units and K1 is equal to 2 and A1 is equal to 3, plus in place of the K2 you substitute K and A2 is equal to 6 and A1 plus A2, that is a 3 plus 6. Then by solving this 6 plus 6 K is equal to 9 into 4, I am solving, you will get the final answer K is equal to 5 units. Therefore now the thermal conductivity of the second conductor, that is equal to 5 units is the final answer.